If you want top-tier reasoning from an AI right now, you are probably paying the standard $20 a month. Google just released an alternative called Gemma 4. It is completely free, it processes text, images, and audio, and it runs entirely offline. Built on the same research as Google's largest proprietary tools, this model lets you power down the server. It runs natively on your laptop. That means you have a choice. Keep paying a $240 annual cloud tax, or move your workflow to a zero-cost local setup. This matrix breaks down the trade-off. We are moving from a rented, cloud-hosted model on the left to owning your infrastructure locally on the right. Your data stays on your machine. Google released Gemma 4 under an Apache 2.0 license. You can drop it into commercial applications or run personal projects with zero restrictions. But to get that access, you lose the convenience of simply opening a browser tab and typing a prompt. You are dealing with hardware reliance. Your physical machine has to do the heavy computational lifting that Google's server farms used to handle for you. Absolute privacy and zero subscription fees are highly appealing, but you pay for them upfront with setup friction and the limits of your own processor. To get started, you install a third-party hub like LM Studio. You search for the model, hit download, and wait for the massive file to transfer to your hard drive. If you are on a desktop or MacBook, you'll likely download the 26 billion parameter version. It takes up about 18 gigabytes of storage space. This diagram shows how a mixture of experts model stays fast. Instead of firing all 26 billion parameters at once, it only activates about 4 billion parameters for any given task. Even with that efficiency, running a model this size creates a severe bottleneck. The speed of your output is tied directly to how much RAM your computer has available. You skip the server latency and avoid internet drops, but you inherit the constraints of whatever hardware you already own. Cloud services strictly meter your context window, the amount of text the AI can remember at one time, because long context eats up their server bandwidth. Running Gemma 4 locally removes that meter. The 26B model gives you access to a massive 256,000 token limit. You can drag and drop an entire book or a complex multi-file codebase into the prompt and ask the model to analyze the whole thing at once. You get the freedom to test, refine, and iterate on massive prompts without watching an API usage meter or hitting a 4-hour lockout. But watch your battery gauge. Asking your laptop to process 200,000 tokens pushes intense thermal strain onto your device. Your cognitive processing is no longer restricted by corporate billing, but it is strictly limited by your machine's cooling capacity. Let's look at performance. When generating code, Gemma processing locally actually spits out results slightly faster than a cloud model struggling on a slow internet connection. The model reliably builds clean HTML layouts, uses tools natively, and keeps hallucinations to a minimum during everyday tasks. This scorecard measures the reality of local execution. Setup friction is higher for Gemma, and the peak logic ceiling belongs to massive cloud models. When coding an interactive game, Claude built a working version on the first try. Gemma wrote the same game, but broken arrow keys required a manual revision. And when generating web interfaces, ChatGPT's design elements look more polished out of the gate. If you need peak reasoning for highly complex problem-solving, the cloud still wins. But for drafting emails, formatting data, or standard code generation, a slight drop in that ceiling is an easy trade for a highly capable free tool. Google also built an edge deployment tier, the E2B and E4B models. These are specifically compressed to run on mobile hardware. You load these onto your phone using an environment like the Google Edge Gallery app, straight from the App Store. The 4 billion parameter version is multi-model. It processes photos and audio recordings right through your phone's GPU. You can snap a photo, switch to airplane mode to kill all network connections, and the model will still analyze the image and generate text. These edge models are stripped down. They lack the parameters to synthesize massive documents or write intricate software. They are computationally lighter, but having true offline analysis in your pocket makes remote, disconnected work entirely viable. So who should actually go through the effort of abandoning the cloud? This decision tree maps 4 primary types of users. Let's start with the mainstream user. If you want quick answers without troubleshooting installations, stick to your web subscription. The setup time outweighs the benefits for casual use. Next is the developer and the tinkerer. The 26B MOE model is your ideal environment. You can test custom system prompts and analyze local code bases for hours without worrying about racking up an API bill. Frictionless convenience carries a premium price. Power users are the ones equipped to extract the real value from unmetered local architecture. Then we have the privacy hardliners and enterprise teams. If you handle NDAs, sensitive client financial data, or proprietary code, sending that information to a cloud server is an unacceptable risk. In those environments, running Gemma 4 locally is mandatory. Finally, we have the nomad and edge operator. Relying on local offline models turns unpredictable environments, like a 12-hour flight or a rural job site with zero cell reception, into fully functional workspaces. Gemma 4 doesn't replace the cloud AI market. It provides a free, private alternative for users who want total ownership of their tools and data.